So today's agenda is to discuss about the decision tree. When we understand a machine learning algorithms, it can be something called as a supervised machine learning algorithm. It can be an unsupervised machine learning algorithm. Coming to supervised machine learning algorithm, we have something called as linear even regression, and one more is decision tree, or else it can be regression and classification on high level. Okay, there are two types of machine learning model: supervised machine learning model and unsupervised machine learning model. In supervised machine learning model, we'll be having something called as regression, and we have something called as classification, regression and classification. In unsupervised machine learning model, of course, we have something called as clustering. Okay, so we understood a couple of algorithms with regression. Now our agenda is to understand about the classification. When we say that we are working on the classification algorithm, the classification can be a linear based model or classification can be a tree based model. When I say the classification can be a linear based model, it comes to something called as logistic regression. It can be something called a supported vector machine. Okay, it is logistic regression. It can be supported vector machines, SVM, and there are a lot more. But when it comes to classification through tree based models, then we have something called as decision tree. Then we have something called as random forest, and so on. Right. So first of all, what is the agenda? The agenda is we are planning to build a predictive model. This predictive model can be built either in a supervised way or an unsupervised way. For unsupervised way, it is something like we don't have the dependent variable. That is right. For example, I want to form some clusters. Cluster one, okay, so many data. Cluster two, so many data. So you don't have the dependent variable. Then that comes to unsupervised learning. When we already have a dependent data, then we call it as a supervised learning. This is what we discussed previously also in our previous sessions, right? So now if I want to build the decision tree, what is the mathematics behind it is the agenda for today. Okay, so first of all, how the decision tree would work. Decision tree can be a binary data or it can be multi-label data also. Decision can be a binary data or it can be a multi-level data as well. What is this binary data and what is this multi-level data? For example, I want to predict, okay, I want to predict whether the person is a male or the person is a female. I want to predict a person is a male or a female. Is a binary data, right? It tells, oh, yes, he's a male or she's a female. Okay. How will you predict the person is a male or a female? Based on the hair length, or it can be the skin tone, or it can be the weight, it can be the BMI, it can be the height. Keeping all these different features, there is something at the end called as gender. We want to predict this gender, right? We want to predict this gender. To predict this gender, we'll be using hairstyle, the hair length, the skin tone, the weight, the height, okay, the BMI, and the last column is gender. Okay. Now the question is, keeping all these features, if you want to classify whether the person is a male or a female, how can you build using the decision tree, or else how can you build using the tree? Now what we do is we'll be selecting something called as a root node. Root node in terms of is a leader. In all these different features like hairstyle, the skin tone, the weight, the height, the BMI, we will be selecting one important feature which is very important and makes our distribution easy. That is, if I select one feature at the first which makes the decision tree to split easily, that feature will be the root node. How will I identify? That is what the calculation we need to do. This is something called as a homogeneity measure. This is something called as homogeneity measure. This homogeneity measure will tell you about homogeneity measure. This homogeneity measure will tell you how much strong is the node or how strong is the feature, right? When I can say how strong is the feature, is that how much is this feature, how much is this feature if I make as a node will support me to make a very big or very beautiful decision tree, or else a good decision tree with a good efficiency. Okay, now it can be a hairstyle which can be selected for, or skin tone be selected first, or a weight, or a height, or a BMI, or a gender. We don't know. So what we do is we take all these features and we try to apply some formula through the which is called as a homogeneity measure. Then we will decide who is supporting us more, right? Who is supporting us more to take the tree further. So what we'll do is we'll be selecting one root node. Based on that root node, we do further calculations. Then we split based on the other three. Here again comes the computation which has to be selected here. Again we calculate with the formula. Then we will see what is happening. Then again we will split a tree here. Then again we will see some formula. Again we will split a tree here. Finally, with the leaf node, which tells whether it is a male or it's a female. This is called as a leaf node. These are called as intermediate node, and these are called as root node. So which node or which feature has to come where, that would be decided using some formula, and this formula are of different types depending upon the decision tree. If you are using some ID3 algorithms, then the formula is different. You're using something called a SCART, okay, the formula is different. Okay, so we have something called a C5.0. So this is something where the formula is different. Depending upon the algorithm what we use, the formulas which is used to split is different, but overall the efficiency will be approx the same. Like, approximately, when I can say there might be 1 or 2% of difference, but overall it's the same, right? So what we need to do is we'll be solving with two different algorithms today for a specific data set, and we will understand how the decision tree would work. Okay, to start with, this is the data. What is a common data? Like I want to specify. We can take some complex data as well, but I don't want to, because we are in a learning phase and we want to understand it better. We have something called as a outlook, the temperature, the humidity, the wind, and depending upon these features, I want to understand whether to play cricket today or not. Okay, this is a previous historical data what they have captured. Next time, keeping this data, we need to predict. I will give you the outlook, the temperature, the humidity, the wind, and you tell me whether you can play cricket or not. Okay, if this is a sense, now what to do? Now what to do is we will be constructing the decision tree taking these features. Okay, so let us say we have taken this data. You can have a snapshot of this data through your mobile phones so that you can keep solving when I give the problems. Please take a snapshot of this. Okay, so now we have our data. I'll come back to the data as well, don't worry. Right, so we have the outlook, we have the temperature, we have the humidity, the wind. Now we want to understand whether to play cricket or not. Okay, the outlook is sunny, the temperature is very hot, and the humidity is high, the wind is weak. So no, we can't play cricket. So what might be the reason? The humidity is high, no? Okay, and the temperature is what might be the reason we are not playing cricket. Okay, so now here the outlook is overcast, the temperature is hot, and the humidity is high, the wind is weak. Here we are playing cricket. Okay, so depending upon the scenario, we don't know. I'll just give the conditions, and we want to build a predictive model to say whether to play cricket or not. To build this predictive model, we are building something called as a decision tree. Let's try to understand and let's start working on building the decision tree now. First thing is we can build a decision tree either using entropy, okay, and the other one using the Gini. I'll repeat. You can build a decision model, decision tree using different steps. One is using the entropy, another is using the Gini. What is this entropy and what is this Gini? Depending upon the algorithm, right? Depending upon the algorithm, either you can use entropy as one of the homogeneity measure to split the node, or we can use something called as Gini to split the node, right? Okay, so how entropy would work and how Gini would work, that we will see. Right, we have something called as ID3 as an algorithm. Okay, there will be using something called as entropy. We have something called as SCART as an algorithm. There will be using something called as Gini. Those are nothing but the homogeneity measures. That is how to split, how to understand which node is valuable. To understand that, we go with the split. Now, first what we do is, I want everyone to take this formula and solve. First thing is, we will take this, calculate the overall entropy. Very, very important. Given this data, I'll tell you how to calculate that entropy. Okay, first thing is, we have already seen the data. Using this data, we are trying to calculate the entropy. What is that overall entropy? The overall entropy, the formula is like this: minus of 9 by 14 log of 9 by 14 plus 5 by 14 log of 5 by 14. What is this? What is this? If you can see this data, overall there are 14 cases. Yes, there are 14 cases. I mean, out of these 14 cases, how many are yes? Let us calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 are yes. How many are no? Of course, 5 has to be no. So what will be my formula? The formula will be minus 9 by 14 log 9 by 14 plus 5 by 14 log 5 by 14, which we will be getting 0.94. Please take this. This is called as entropy of the class variable. The first step to find out the overall entropy. Okay, that is a root entropy. I can call it as a root entropy as well. Okay, this is the entropy of the class variable. First thing we have to do this. Why are we doing this? You will understand. Okay, why am I doing this manually? This is how the decision tree is built and the algorithm is built in Python. We just use the sklearn package and we call the package and we start building the model. Provided inside that sklearn package, all these things would have been already done. We are just using it thanks to Python. We are not writing this all because we don't want to do because already written. Provided we don't even do right, if we don't even write line by line code also because not required. Our intention is to build a model, not exactly to reinvent the wheel. That is doing the same thing again and again. Not required. We just use the package. But as a good machine learning engineers, we need to understand how it is happening. If you don't know how it is happening, then you can't do the performance tuning, you can't do the hyperparameter tuning, and you will get stuck. You don't know how to take it forward. This is a problem with most of the people. Without knowing the mathematics, if they learn machine learning, this is a problem. Okay, we have to understand the mathematics behind the machine learning, right? So here what happens? You already have the data 9 by 14 log 9 by 14, 5 by 14 log 5 by 14, which comes to 0.94. And I've given a note here. Typically, we will take log to base 2. Here total there are 14 s and no, out of which 9 s and 5 no. Based on it, we calculate the probability above, right? So please make sure you just calculate it and you're getting 0.94. I'll be giving you a minute of time. So we'll be calculating 9 by 14. What we get is 0.648, right? So 0.6428. For this 0.6428, we'll be calculating the log. That is log base 2 of 0.6428 you need to do. Please don't make a mistake of calculating log of 9 by 14. So according to logarithmic principle, log base 2 of 9 by 14 will be again log A minus log B. So don't do that mistake. So when I calculate minus 9 by when I divide 9 by 14, we get 0.6428, and when I take log of 0.6428, we get minus 0.637. This is one value. 5 by 14, we get 0.353, and log base 2 of 0.353 is nothing but minus 1.486. Then we'll be calculating this minus. Listen to minus is minus, so minus 0.409. Again, pressing to minus is minus 0.524 or 529, right? So again, one is minus, so both are minus, so we need to do addition. So addition of minus 0.938. So minus into minus will be plus. So answer is plus 0.938. We are taken into plus 0.94. This is the overall formula to calculate the entropy. Okay, this is something which is very, very basic to understand if you are a machine learning engineer, because the logarithmic principles, trigonometric principle, at least not to an extent of to becoming a mathematician, but to some extent, yes, we require to do all these things. Okay, and this was the first step. Now, from the above data, please concentrate now. We are at the next level. We got the overall entropy. I'll be getting this table. This table is in Outlook. I'm just taking that Outlook. So what are different features? The different features what we have here is, I don't know. I have to calculate what exactly is for the Outlook. So what exactly is for the temperature? What is for the humidity? What is the wind? How much it is supporting for humidity? How much it is supporting for Outlook? How much is supporting for temperature? How much is supporting for, I don't know which is good to take as a root node. So I will be calculating the entropy for Outlook, entropy for temperature, entropy for humidity, entropy for wind. So I'll be calculating for each and every value. Let us try to understand this now. Okay, so when I say I'm calculating the entropy for humidity, Outlook, how we do? So there is Outlook. In Outlook, there are three called as sunny, overcast, and rainy. This is very important. This is how we need to plan for a table. Please take down. So we have Outlook. In Outlook, we have sunny, overcast, and rainy. Okay, then we have the play. Either he can play or he might not play. So yes or no. Fine. So totally what we do, if the Outlook is sunny, how many times he's playing? Let us go and check. If the Outlook is sunny, how many times play is yes? Outlook is sunny, Outlook is sunny. Oh, yeah, play is 1, 2, only 2. So if it is sunny, 3. Yeah. So if this no, only 2. So when the Outlook is sunny, he's playing only 2 times. I understood that, then I written. Outlook is sunny, he's playing 3 times. Let us check how it is 3. Outlook is sunny here, no. Sunny, no. Then sunny, no. Sunny, yes, 1. Okay. Then sunny, yes, 2. Right. So let us check. Outlook is Sunny 1, 2, right? Okay. What was the mistake in the table? So Outlook Sunny, then no. We'll see how many times it is no. Outlook is Sunny no. Sunny is there here, so it is no 1. How many Sunny no 2? Okay. I think there's a small mistake over here. You can just recorrect this table. Okay. Outlook Sunny, yes, it is actually 2. Outlook Sunny no is actually 3. Right. So totally it is 5. Let us check for the Outlook as overcast. Let's see for Outlook as overcast what happens. When the Outlook is overcast, how many times is playing? Outlook overcast is there how many times? 1, 2, 3, 4 times. In 4 times, how many times it is yes? Here 1 yes, 2 yes, 3 yes, 4 yes. Oh, when Outlook is overcast, all the times it is yes. So no is 0. Good. When Outlook is rainy, then what? When Outlook is rainy, how many rainy are there? 1, 2, 3, 4, 5. 5 rainy are there. Out of 5 rainy, how many is yes? 1, 2, 3, 4. Okay. 3. Okay. In Outlook is rainy, there are 3 times it is yes. Okay. So we are 23 times it is yes. 2 times it is, 2 times yes, 3 times it is no. Correct. So overall we got 3 plus 2 5, 4 plus 0 4, and 2 plus 3 5. Overall we got the 14. This is the first step. We need to make this table. We need to make the same table for Outlook as overcast, Outlook for for temperature, for humidity, and for wind. Now what we made is for Outlook. After that we will compare how much is Outlook contributing to be the root node. Outlook, how much is temperature contributing, how much is humidity contributing, how much is wind contributing. So based on that homogeneity measure, right, based on the impurity, right, I must not the model must not be confused. Our intention is to make sure the model must not be confused, which will contribute more. Okay, so that this homogeneity will be there. That is the understanding of the data, understanding of the overall model or overall data is easy for the model. That would be selecting as a root node. So how is it? That is a calculation what we are doing. So first we will calculate for Outlook. Now how to calculate for Outlook we will see. We will take something called as 5 by 14. What is this 5 by 14? And what is this 3 by 2? Go for the first table. Here we have got 5 by 14. The overall entropy, that is in Sunny, for Sunny. Okay, for the Sunny, as you can see, it is for S of Outlook. It is for the first one is Sunny. For the Sunny, it is how much? 5. Okay, the table is 5 out of 14. Okay, that's what we written. Then into entropy of 3 by 2. What is entropy of 3 by 2? For Sunny, it is 5 by 14. Okay, out of it is 5 by 14 that we calculate. Then we calculate the entropy of 3 by 2 plus. I'll repeat, just concentrate. Overall, it is how many? First, we need to calculate. First, we are trying to calculate the overall entropy for this Outlook. How much is Outlook contributing? That is what we are trying to do. So to calculate for this Outlook, we have calculated this table. It is very much clear now how to calculate this table is done. Now what we do? Is we'll try how many Sunny are there? So 5 by 14. So 5 by 14 into entropy of 3 comma 2 plus what is next? Next is overcast. Overcast is 4 by 14. 4 by 14 into entropy of 4 comma 0. Okay. What next? Next is what? Next is again 5 by 14. 5 by 14 into entropy of 2 comma 3. Oh, now we need to calculate this entropy of 3 comma 2, entropy of 4 comma 0, entropy of 2 comma 3. Just like how we calculate the overall entropy, then we'll be getting the entropy for Outlook. So we need to calculate this. How to calculate this? I'll show you once again. Right? To calculate this, we come back to the table here. We'll check. Okay, so how to calculate 5 by 14 into 3 by 2? Yes, 5 by 14 into 3 by 2. 4 by 14 into 4 comma 0. Yes, 4 comma 0. 5 by 14 into 2 comma 0. Correct. Now, how to calculate the entropy we saw previously? How many it is? 3 plus 2 is 5. So minus 3 by 5 log 3 by 5 minus 2 by 5 log 2 by 5. Correct. Plus 4 by 14 into 0. Because we will calculate something called as 4 by, overall the value is 0 by 4. Again, it will be 0. So directly we are calculating it as 0. Okay. So this is very straightforward because here we have 4 comma 0. Then again 5 by 14, that is 2 by 5 log 2 by 5 minus 3 by 5 log 3 by 5. So overall, if we calculate, the entropy for Outlook would be 0.693. Okay, if you calculate the overall entropy, the entropy for outlook is 0.693. This is not an overall entropy, there is one more step for it. Okay, what it is, I'll tell you. But 0.693 is the answer what we go for outlook. Okay, the next step is we need to subtract. We need to subtract the overall entropy what we got previously. What is the overall entropy we got? The overall entropy is 0.94. What is the entropy you got for outlook? 0.9693. Subtract 0.94 minus 0.693. 0.247 is the information gain. It is the IG, it is the information gain. So information which we can gain out when we take outlook as a node is 0.247. I repeat once again, this is very, very important. Okay, so we calculated this table. Then now we need to calculate this table just like for outlook also, for temperature also, for humidity also, for wind also. Now we are calculating for the outlook. For the outlook, we have something called a sunny, overcast, and rainy. So we have play as yes and no. Okay, so out of this table, we are trying to do now 5 by 14. Why this 5 by 14? Because when I say sunny, it is 5 times. Sunny is there out of 14, so 5 by 14. Individually, to calculate the entropy, we need to put 3 comma 2. So formula is 5 by 14 in E of 3 comma 2. So how to calculate the entropy? The entropy formula is very simple. Minus 3 by 5 log of 3 by 5 into 2 by 5 log of 2 by 5. Okay, that's the formula what we want to do. I will be showing that also. So now we calculated this for 4 by 14 into E of 4 by 0, 5 by 14 of E of 2 by 0. We are done with this. Now if I try to calculate 5 by 14 minus 3 by 4 log of 3 by 5 minus 2 by 5 into log of 2 by 5 plus 4 by 14 into 0, 5 by 14 into 2 by 5 log of 2 by 5 minus 3 by 5 log of 3 by 5. This is a formula for the entropy what we are calculating for the outlook. After that, we need to subtract this outlook entropy to overall entropy. The overall entropy is 0.94 what we got. To get the information gain on outlook, we subtract 0.94 with 0.693. So the information gain what we got for outlook is 0.247. Okay, this is what I want you people to do. Now, this is something which will be there on the screen. I want you people to calculate, okay, the information gain for temperature and let me know what is the gain. Okay, so what is the entropy for temperature and what is the entropy, what is the information gain for temperature? I want you people to calculate and I want you people to do it now. Okay, so first thing is we're writing a table like this for the temperature. So we understood the formula. This will be there on the screen. Okay, so I want you people to put this on the screen and I want you people to calculate the information gain for temperature. Make it fast. So this was a question where we asked you people to calculate. Given enough time, we wanted you to solve the answers and we were expecting to find out the information gain for temperature, information gain for humidity, and information gain for windy. Of course, it has to be practiced. It's not that something you can just say, no, let me do in the interviews. Okay, let us solve when the interview question is given. Trust me, if you're not able to do it now, 100% you can't do it in interviews. Okay, that's for sure. Because you know, right? If you're not even able to practice it, then how can you go and execute it in interviews? Not possible. It's not the sake of interview what we are actually learning this. This is the most beautiful concept. You'll enjoy it if you start solving. So now the IG for temperature was somewhere around 0.940, okay, minus 0.911, right? The people who sent the answers as 0.911, who got the answer as 0.911 for temperature, very good. The answer was 0.911. So it is the entropy gain. Entropy gain was 0.911 and the overall entropy was 0.940. So we are subtracting 0.940 minus 0.911 and we got 0.029 for temperature and we got 0.152 for humidity and we got 0.048 for windy. This is the answer what you people must get. Okay, if you're not able to get this, then make sure you made some mistake. So the temperature, it is 0.029, the information gain. For humidity, the information gain is 0.152. The windy, the information gain is 0.048, right? So what we do now is, after getting all these values, now we need to decide what is the best information gain. So now select the features having the largest entropy gain. Here it is outlook. Yes, of course, for the outlook, what was the information gain we got? It was 0.247 for outlook, 0.029 for temperature, 0.152 for humidity, 0.048 for windy. So we understood the outlook has the maximum information gain So we select the Outlook as our first decision tree node. Okay, this is how we need to do. So what we do now is further when we take the splitting of the tree, what we do first, we will take a root node as this. Root node must be Outlook. Then in this Outlook, we further select. Okay, so Outlook is what? Whether Outlook is, I know which feature of Outlook. If you can go and see the screen, the Outlook is of multiple types, right? The Outlook can be what? The Outlook can be sunny, it can be overcast, it can be rainy. So in that where do we stand? Like which one to be taken? Whether Outlook the sunny, then what? Outlook rainy, then what? Okay. So depending upon that scenario, we need to further calculate. That is the next step of problem solving. Then we keep on solving like this, then it will take a lot of time. We are not solving in real time. No, we are using the packages. But I want you to understand how the decision tree is actually built. Lot of computations are happening, and we are using entropy as our homogeneity measure. Okay, entropy can be used as an homogeneity measure, or you can use something called as a child. You have something called as chi-square method. Okay, that is one of the method where we can use, right? There are, depending upon the algorithms, there are different homogeneity measures, right? The different homogeneity measures provided. As of now, we are using something called as entropy. Okay. So how to calculate? So we got to know this is what the temperature, humidity, and the windy. How to calculate? We given the sufficient time for people to calculate, and we got to know the temperature. It was 0.029, humidity 0.152, windy 0.048, and if you want, you can just take a snap of this so that you can practice it. Provided now the highest information gain for the Outlook. So we selected Outlook as our first node, first parent node. Provided we are not stopping here, what we do now is selecting Outlook. We want to say for Outlook is overcast, Outlook is sunny, and Outlook is rainy. Again, we'll be forming a table like this. For Outlook overcast, what are the temperature, humidity, wind? For Outlook sunny, what are the temperature, humidity, wind? For Outlook rain, what are the temperature, humidity, wind? So how many have we have totally? Totally we have 4 of overcast, 5 of sunny, okay, then 5 of rain. So totally 5 plus 5, 10, 10 plus 5, 14, 10 plus 4, 14, 14 values are there here. For overcast, so what are the values? What is the temperature, humidity, wind? Okay, and for overcast, cool, normal, strong, yes. Mild, high, strong, yes. Hot, normal, weak, yes. So this is what it is. Again, for sunny, we go refer to the table, and we refer to the main table, and we calculate we bring up to the table like this. Again, we'll start doing the calculation. How? The same calculation what we did previously like this. Okay, so IG of temperature, humidity, and windy, we try to calculate once again. Now, since overcast contains only one examples of class S, we can directly say yes. That means if Outlook is overcast, football will be played or cricket will be played. Okay, now decision tree looks like this. How? It is like this. If you can see, okay, so if it is Outlook, I don't care of anything else. Directly I say if Outlook is sunny, overcast, or rain, without anything, directly say yes. See, if I can just go back and refer to the table. In this table, you can see Outlook is overcast. Was whatever the other scenarios is. If Outlook is overcast, I don't care of anything else. Directly I say go and play football. Simple. If Outlook is overcast, directly go and play football. How did you come to the conclusion? Very simple. When I was able to solve the decision tree, I took Outlook as my root node, and in Outlook as my root node is being taken. Again, this Outlook is further has 3 things, which is nothing but overcast, the sunny, and the rain. I'll ask the user, okay, so what is the Outlook? Is Outlook the overcast, or is Outlook sunny? Okay, or if Outlook rainy, I'll ask this. If you tell me the Outlook is overcast, okay. If it is overcast, then what we do is we will try to predict, okay, whether to play football or not. Why you want to make a prediction was whenever the Outlook is overcast, without anything else, directly you say yes. Then this would be the leaf node. Finish. If Outlook was sunny, then depends again whether to select temperature, whether to check the temperature or to check the humidity or to check the wind. Now that is again the computation what we want to do. Again, if it is rainy, then we want to tell the temperature, the humidity, and the wind. Here's the computation. Now which one to be selected next? That we can decide for sunny and rain. But for Outlook, directly if it is overcast, then we can say it is yes. This is how the tree is built. Now next what? Next we need to further calculate. Further calculate for what? For Outlook sunny and for Outlook rainy. Further we need to calculate. How to calculate that further? Very simple. Whatever we did till now, it is the same procedure. The next step is to find the next node in our decision tree. Now we will find one under sunny. We have to determine which of the following, temperature, humidity or wind, has higher information gain? Correct. See, here we have temperature, humidity and wind for sunny. Now what has to be selected for sunny? Whether next after sunny has to be the temperature, next after sunny has to be the humidity, next after sunny has to be the wind. We don't know. Again the competition, again start solving the problem. How? The problem is this, the program is, the table is this. Now we want to calculate the overall entropy for sunny. Okay, overall entropy for sunny is what? Minus 3 by 5 log 3 by 5, minus 2 by 5 log 2 by 5. Just like how overall entropy we calculated for the root node, it is 9 by 14, 5 by 14. Like that we are doing for sunny. Okay, it is minus 3 by 4 log 3 by 4, minus 2 by 5 log 2 by 5. It is 0.971 is the overall entropy for sunny. Now again, individual entropy for sunny. What? For temperature. For temperature, calculate this table. It is such a long procedure. Of course, yes. Imagine your our systems will do within fraction of seconds. That is the computation, right? So only what we do, which is really difficult to calculate to humans, we do a lot of algorithms and we make our computers to do it. Okay, as simple as that, right? So this is a procedure actually which is happening whenever you try to predict, understand the complexity behind it. Every time when you do prediction, it appears with a fraction of second for us, but so much of computations are happening in the backend. So only machine learning is all about mathematics and calculations, right? So what we do now, we calculate again. Okay, so for sunny, it is what? For temperature, we have considered only sunny, then temperature I'll take and calculate the table like this. For humidity, I'll take and calculate the table. For wind, I'll take and calculate the table. Then I'll subtract overall entropy for sunny minus individual entropy for sunny. Then I'll subtract and get the answers. So what it is? So sunny of temperature is 2 by 5, E of 0 by 2, 2 by 5, E of 1 comma 1, 1 by 5, E of 2, 1 by 0, 0. So we got 0.4. Now what? Now subtract. Subtract what? 0.971 minus 0.4. Anyways, I'll be forwarding this table for you people. This entire PPT so that you can revise it. That's not a problem. So what we do is now subtract 0.97 minus 0.4. So we got the information gain for sunny under temperature is 0.571. Okay. Similarly, we calculate information gain for sunny under humidity, information gain for sunny under wind. Okay, we are not stopping. Then again, we calculate information gain for the other two things. What? So we have what? We have rain. So rain under temperature, rain under humidity, rain under wind. This process continues. When I then given an interview, like how many notes to do? If we can solve at least to one level, that is more than enough, so that the people understand, the concept. Okay, it's not that we need to solve the entire thing and you need to give the solutions. At least one level of root node, what has to be selected. If you're able to do that, I think that would be really fine for you people. Okay, to answer in the interviews. That's more than enough. Okay, so if I can say for the sunny of temperature, we got a 0.4. Okay, so when we subtract it, we get 0.57. Similarly, when I try to calculate, okay, for humidity, we get 0.971. For windy, we get 0.020. So here the information gain for sunny is the largest value. So humidity is a node that comes under sunny. Okay, so now we have overcast, we have sunny, we have rainy. First is outlook. Under outlook, we got overcast, sunny, and rainy. This is for sure because we decided outlook is our first node. In outlook, we have 3. In that 3, we have overcast. Then directly say yes, don't check anything. In sunny, either we need to check for, you need to compete between humidity, windy, and like sunny, right? So here what happens? Here what happens is sunny with humidity, sunny with windy. Okay, we want to check it. Okay, sunny with like we have 3 different things, right? Sunny with temperature, sunny with humidity, sunny with the wind. Okay, now what we do, we try to calculate for everything. So we understood that sunny with humidity is the largest value, which we are getting 0.971. So we further say next node is sunny with windy. Then again the competition begins with what? With the temperature, okay, and with wind. Correct, right? So that's how it is. So sunny further try to calculate with hot, mild, cool. The process continues. The process continues. There is no stop. Where will we stop? When we say that there is no further split and entropy branch will be 0. What do you mean by entropy branch is 0? Just like how we saw for outlook, overcast, directly it is yes. Till that we calculate. See, in outlook overcast, directly it was yes. Okay, outlook is okay. There is no chance for us to split. There is no something like yes or no. There is no something like A, B, C. There is only A. It is only B. It is only C. Then stop. okay, or it is only one value, then stop, just like overcast. Till that point, we keep on calculating the values like this. So our tree further would look something like this finally. So outlook, okay. Then outlook is sunny, overcast, and rain. Okay. Then I've selected sunny. Then under sunny, you have to select humidity. Okay. Now I'll check for humidity, high or normal. Okay. Overcast is that directly play yes. Okay. Now I'll check what is the rain. Okay, it's rain. Then I'll check for wind. If wind is strong or weak, okay. If it is strong, then what? If it is weak, then what? This is the process. This is the process. Now, given the question like this, okay, keeping this tree when given the question, okay, so wind strong, no, okay, it is raining, yes, okay, outlook, no, tell me whether to play or not. So depending upon that, we can trace back the tree, and we can get the solution whether to play or not. This is how we do predict. Once when we say predict, automatically the model traces the tree, then it will be giving us the output whether to play or not to play. This is the overall mathematical calculation behind the decision tree using entropy. Okay, using entropy, this is the problem. This overall procedure, what we keep on doing it. This would be done for millions of records. It can be done for, okay, like thousands of records. Like machine will do. We are not bothered about it because we just write the formulas, we just write the algorithm, and we call the algorithm, and machine will do it and gives a solution for us. Okay, we try to do for a simple data set to understand the mathematics behind building the decision tree using entropy. So we have solved using the entropy. If you ask me, is there any other methodology to construct a decision tree? Yes, there is one more methodology. Okay, what it is and how it is. Okay, let's check. So we have something called as Gini. Okay, so Gini is one of the way. I told you one of the method is using the entropy, other one is using Gini. We have something called as chi-square. The depending upon the algorithms, the homogeneity measure changes. If you're using something with respect to the cart, then I say you can go with Gini. I say I'll be going with ID3 algorithm. I say go with entropy. I say I'll be going something called as chi-square. I mean chi tree. So CHAID chi tree. Then I'll be telling that go to for chi-square. So depending upon the different authors, depending upon the different algorithms built, the homogeneity measure changes. Let's say that I want to calculate with respect to Gini. So what to do? The procedure remain the same. I mean, the overall procedure is like calculate, fight between the root node, then come to the conclusion that remain the same, but the formula changes. That is, in Gini, what we need to do is first we need to calculate the Gini index for the dependent variable, which is a class. So what it is, 1 minus 9 by 14 the whole square plus 5 by 14 the whole square, which is 0.459. What it is? It is overall how many S we had? We had somewhere around 5 S. How many no? Around 9 no's, let's say. So it is like 1 minus 9 by 14 the whole square plus 5 by 14 the whole square. This is Gini of the class variable 0.4591. Step number 1. Okay. Now, as a step, we need to calculate the Gini gain for individual nodes. As usual, we need to calculate for outlook, temperature, humidity, and windy. We know how to get to this table. Correct. This is the table what we get. Now what we do? Now what we do is the same thing. 5 by 14 Gini of 3 by 2. 4 by 14 Gini of 4 by the same thing. There is no change here also. The only change is there we were using entropy of 3 comma 2. Here using Gini of 3 comma 2. This is the only difference. Nothing else. Here we'll be using Gini of 3 comma 2. They're using entropy of 3 comma 2. So how the difference? Like what happens? I told you in entropy, what we used to do in entropy, the formula would be like 3 by 5 log of 3 by 5 minus 3 by 2 by 5 log of 3 log of 2 by 5. Here what happens? It is like this: 1 minus 3 by 5 the whole square minus 2 by 5 the whole square. This is a formula for Gini. Okay, then 5 by 41, 5 by 14 as usual. My 1 minus 2 by 5 the whole square minus 3 by 5 the whole square. There we used to take the logarithmic value, we need to calculate it. But in Gini, we use 1 minus the probability of the individual values. This is how we do. Finally, we get for Gini of outlook to be 0.342. Similarly, we get Gini of the other values as well. So we need to calculate for outlook, we need to calculate for the temperature, we need to calculate for the wind. Then we'll be getting to a conclusion. If we keep on solving, here also we get the outlook for the Gini gain for outlook is 0.117. The Gini gain for temperature is 0.0185. The Gini gain for humidity 0.0916, the Gini gain for windy 0.0304. Okay, we can calculate like this. Again, we can see higher Gini gain. The higher Gini gain is outlook, so we select outlook as the first one. There is no difference. The only difference is the formula. Might be here and there efficiency might change to some extent, but there are different ways. If you can ask me, hey Vinay, then which formula to use? Of course, this is a trial and error method where I can't directly say we use ID3 for this data, use cart for this data, then here use child. There is no such process. We can try with child, we can try with decision tree, then we can try with ID3. You can get which model is giving the best, select that model. That's how is it. Okay, there's some concept called as pipeline of machine learning models where we can discuss later. In that case, we will be selecting which model to select at the best. Okay, so what overall the problem is, like, we don't actually keep on solving this in practical. We'll be using the machine learning packages like sklearn, provided what we want to understand is this is a problem. This is a numerical execution which is happening behind each and every algorithm. So one was the entropy, other one was the information gain. So this is how the decision tree works manually. If you want to work it manually, this is how it is like. I mean, of course, you don't get a chance to do it, and we can't even do, because if I have around 200 to 300 data set, or 200 to 300 rows of data, I don't think so it would be possible for us to execute manually. That's the reason we have written the algorithm, and algorithm takes care of it. But the problem solving approach is this. Okay, so if given, okay, if given a chance for you people to construct a decision tree, you can either select entropy or either you can select information gain. Specifically, if they ask entropy or information gain, go for it. We have understood how to solving both the approaches, right? If they're asking a child of choice, we can't learn each and everything. Okay, it's good if you're really passionate, you can do that, or if you really want to understand, you can do. But understanding one or two formulas is more than enough for you people. Right? So this is how we calculate using Gini. This is how we calculate using the entropy, and how to build the decision tree.